So again, greetings. So now we have to continue with our previous discussion. So I hope you can able to remember what is error measurement. So what we said and shared that earlier, that relativity between the estimated population value and with the sample the true value and with the true value for the population. So always the standard error estimate that measure of the magnitude of the difference between the sample and the population parameters. So that is very important, and keep in your mind it's purely the estimation value of your sample and from the true value. That is so simple. The error that making the difference between the sample collected and from the true value of the population. So now we have to quickly see the formula so behind to compute the error. So the standard error, it's applied for that standard deviation of the sampling. Already we know the standard error of the mean, that means SEM, that has been expressed as the SE, that is representing that standard error of the mean. So that is the SE of the x bar equal to standard deviation, that's divided by square root of n. So already in a previous episode we discussed what is the capital N and what is the small n. So capital N always represents the whole population. The small n always represents the sample population. The n number of the sample population always represented in that small. So the standard error mean, it's having the computation of you have to be find, that is the standard deviation of your sample, that should be divided with that square root of that n. So here the S that is represented the standard deviation of the population, and n is the size of the number of the sample. So this is the standard error. So now we have to go with the relative standard error. So in the relative standard error, here we are expressing the standard error as a portion of an estimated value. So in RSEs, that means in the relative standard errors, we are doing that is the useful measurement, and also we are providing that certain indication to the relative size of that error that can able to occur due to that sampling. So the high RSE and the high value of that RSE that indicates that less confidence, and the low value of that RSE, it's having that very good confidence in the true population. So this is the representation of the standard error. So now we have to quickly see what is the primary difference between the standard error and the relative standard error. So the standard error measure and indicates the extent of survey that is estimated so likely to deviate from the true population. That means from the truth value, how much of deviation is happened in the sample. So that's all talk about, that is the standard error. But in a relative standard error, here we are going to be express the estimation is in the fraction or in the form of percentage, that is the expressed as the in percentage. So there we are getting that is that value in standard error. So already we know that is the formula. So the SE of the x bar equal to SD divided by square root of n. There we are getting that is the certain numerical value. But in relative standard error, we are getting the value in the form of that percentage. We are having that certain indication. Immediately we can able to be understand that how much of the error that has been happened in between the collected sample and with the true value of that population. So rather than finding of that standard error, that is that very much better when you are going with that industry or that, so anything, if you are computing with a relative standard error, so that's giving the very good outcome for you. Okay, so now we have to see about that is the probable error. So this probable error is always defines about the thing is from the center point, that is the half of the range that has been accumulated towards that center point, and the remaining half of that value that has been lies between a certain interval from the outside of that center point. So this error is called, that is the probable error. So on the next video we are going to be see about, so what is the probable error, how we have to compute that probable error.